All right, well, let's talk about Wireshark. Here's Wireshark, of course, is used to analyze network traffic traces. You really shouldn't be monitoring live traffic data with Wireshark because it's not secure enough, but it's good for analyzing packets you captured with another tool like TCP dump, for example. So here's the first one to try an FTP login. This is old classic stuff. And you can install Wireshark on any operating system with graphics. There's even a cloud version called CloudShark, which is pretty limited, and I don't like using it much, but it's an option for people who can't install Wireshark. But you can run Wireshark on almost any operating system. And it should be loading. Here it is. All right. So here's that FTP login. All right, let me move my instructions to the side so I can follow them along. Okay. So here's my Mac locally installed version of Wireshark. All right. And so if you expand the packet, the middle pane here, you get to see the layers of the OSI model. The frame shows the raw packet at layer 1, 78 bytes on the wire. Then layer 2 is Ethernet with MAC addresses. Layer 3 is IP with IP addresses. And layer 4 is TCP with TCP port numbers. And that's so to find an FTP password, in this case, scroll down here. This is an FTP login. And so there's other kinds of traffic besides FTP, but you can filter here in the filter bar for FTP, and then you'll see the FTP, and right here you can just read it right here. FTP doesn't encrypt anything, and it's so simple. The packet summary here just shows you login with user and password. So here it is with a username and a password, and then the result of login. There's a few logins here, so you can find a flag just by reading those. So that's the simplest case. Now the next case is an HTTP login. So let me open this one. All right, it's open. Now I have to stop filtering for FTP and filter for HTTP instead. All right, and again, nothing is encrypted, but this one is using this is a plain text login, so you can see the data sent down here in the middle pane. This is one way to do it. You can expand this, and you'll see the request here. And so this is a gets login form. 200 OK, it got it. Then the favorite icon on the page. Here's where it logs in with a post login. So if you go down here, here's the HTML form data being sent. Here it is sending data, Isaac and Flapper. And here's the results, 200 OK, showing you entered it, but login denied. So that was the wrong password. Here it is trying to log in again with a different password. And here's the post showing login denied, and so on. You can go through here and find out the name and password that actually got the user in just by following it in the middle pane. And there's another way to do it that is usually more efficient. If you right-click and follow the TCP stream, then you will see just the data the way the user saw it without any addresses or anything. Here's the get, here's the reply. But one thing that can happen is the data may be compressed, so it's hard to read. All right. Anyway, but here you can get it just by looking at the middle pane. All right. And so there's a few simple things to do there. Now another one to try is basic authentication. This is an old system. It's still used sometimes. It was an early attempt to avoid sending passwords in plain text. So this is the basic login PCAPs. And if you filter again for HTTP, then you see the way it works is you'll try to load a page and it will return an unauthorized message to the browser. then the browser will pop up a box asking the username and password from the user and send it again. So the first get here has usual headers here, like host and user agent, and the reply is 401 unauthorized. But the next get repeats the same thing. Now it has this authorization line, which includes the username and password from the user. And you see it's unreadable here, but it's not encrypted, it's just encoded with base 64. And if you expand it here, Wireshark will decode it from base 64. So that's basic authentication. So that's another one to try. And the last one is more interesting, especially for the more advanced people. This is from a red team CTF called APT capture. And there's a whole series of things to solve here. Quite a lot happening in this PCAP file. There are some encrypted transmissions, so you have to use the menu bar in Wireshark and go to Statistics, Protocol Hierarchy. Oops, not Conversations, but Statistics, Protocol Hierarchy. Machine is acting up a bit. All right, Statistics, Protocol Hierarchy is here. All right, now you can see when this comes up. All right. So you see various protocols here, and only a couple of these are encrypted, TLS and SSH. And SSH has only one packet, so it wasn't used. So this TLS is the encrypted protocol that's used, and it turns out that what happened here, you can follow through the steps, and you'll find a protocol here. Then you'll find that it used an unusual port number, not the default port number. And you can find the frames that were used to set this up. The attacker got a command line shell on the target and executed Linux commands to create an encryption key and then start an encrypted channel of traffic over TLS, and you can get the key and you can decrypt the packets. So there's a whole series of steps here where you track down this attack. And I can help people. I left some hints here, and I can also answer questions. It's pretty fun to analyze what they've done there, and you get some practice using the more advanced features of Wireshark. So I'll stop that recording.